This is the second video for categorical analysis. Suppose a clinical trial is conducted to evaluate a diagnostic screening test designed to detect chromosomal fetal abnormalities. Chromosomal fetal abnormalities are confirming using amino synthesis. The diagnostic test is performed on a random sample of 200 pregnant women who later undergo an amino synthesis. In the 2x2 table here, we can see out of 200 women, 14 women who got positive diagnostic test confirmed abnormal using amino-synthesis. 6 are negative diagnostic test but abnormal. 64 are positive diagnostic test but normal, and 116 negative diagnostic test and normal. We can see 14 women are abnormal aminosynthesis and correctly diagnosed, and 116 women are normal and correctly diagnosed. Other two numbers, 6 and 64, are the misdiagnosed cases. A few common measures are listed in this slide. The risk first, the risk is the probability of success or positive test here. Thus, the risk of the positive test is 14 out of 20, all abnormal aminosynthesis. And the risk positive test is 64 out of 180, all normal aminosynthesis. Okay, the sensitivity is a conditional probability of being diagnosed positive among abnormal aminosynthesis, which is 14 over 20 in this example. Specificity is a conditional probability of being diagnosed negative among normal aminosynthesis, which is 116 over 180 in this example. The predicted value positive is a conditional probability of being abnormal among positive test results. Here, 14 out of 78 positive test results were abnormal. Predictive value negative is conditional probability of being normal among negative test results, which is 116 out of 122. False positive is a conditional probability of being normal among positive test results, which is 64 out of 78. Among all those words, I would say, sensitivity and specificity is actually something that people use quite a bit. So just want to point out that those are common words people use. Now we will look at how we can compare two proportions. A college professor wished to know the passing rates are different for online and in-person basic statistics course. The passing, failing numbers of 1,000 students who took basic statistics course from 2022 to 2023 were summarized in this table, still 2x2 contingency table. We can say the passing rate for online class is 324 out of 400, which is 0.81. And the passing rate for in-person class is 512 out of 600, which is 0.85. It seems that the in-person class has higher passing rate, but the question is, are they statistically significantly different? One way to answer this question is to do two sample proportion z-test as shown in the slide. We can find the structure is very similar. The hypothesis test structure is very similar to one sample proportion z-test, except Now we are comparing P1 and P2, both from samples rather than P1 and P naught, where P naught is a constant value in one sample proportion Z test. Theoretically, two-sided, two-sample proportion test Z test is the same as chi-square test. In practice, chi-square test often used for such tests, and will be exactly identical. And you will see more it will make a little bit more sense when we talk about chi-square distribution a little bit more later. In R, we can use you can still use prop.test function. We can add the number of successes and the sample size for two group in order. The default for alternative is two-sided. Here are X values, and here are N values. And what I mean by in order is the first number and the first number of X and first number of N is actually from the same group, and 512 is out of 600. The gray box is the results from prop.test function. We can see the test statistics is 2.9786, and the chi-square chi-square statistics value, and this is the square of Z statistics value from the previous slide. And this will make a little more sense in the next video again, where we learn details about chi-square distribution. But again, it's actually identical. You're comparing chi-square value to the chi-square value to calculate the p-value. And in the previous slide, when you're using Z, you will be using p-value that is calculated based on Z. And then theoretically, mathematically, those are actually will always give you the same answer. Corresponding p-value is 0.08437. There is no statistically significant difference in passing rate or their performance between online and in-person basic statistics course, since p-value is 0.08437, which is not less than the significant level 0.05. We can also see 95% confidence interval for proportion differences, including, this includes 0, right? One is negative value and one is positive value. So 0 is included in the interval, which also implies that there is no significant difference.